Welcome friends. In this video we find upper sum and lower sum of some functions and check whether the function is integrable or is not integrable. In the previous video we have seen upper sum and lower sum and the definition of integrability. Whenever upper integral is equal to lower integral, the function is said to be integrable or a Riemann integrable. So this is the definition of Riemann integrable function. You can watch our previous video on Riemann integrable. Discuss with some function. Suppose the function is f of x equal to k and the interval is a comma b, and we want to check the integrability of the function. Then we know that this function is a constant value. Hence, if we take any partition p of this interval x0 x1 up to xn, then this is our x0, a equal to x0, this is our xn, that is b, and all the remaining point lies between this a and b. And in any interval, for any interval x0 to x1, suppose here the value of the function f of x is equal to k, same value. Hence capital M1 equal to k and small m1 equal to k. In fact, capital Mi equal to k equal to small mi for all I equal to 1 to n. Then friends, what is upper sum? Upper sum of the function equal to capital M1 into delta x1 plus capital M2 into delta x2 plus capital Mn into delta xn. What is capital M1? Capital M1 is k. Everywhere we have upper supremum is k. So k into delta x1 plus k into delta x2 plus k into delta xn. We can take k common, then delta x1 plus delta x2 plus delta xn, and this is nothing but total value k into x0 minus x1 minus x0 plus x2 minus x1 plus xn minus 1. x0 x1 get cancel, x2 get cancel. Similarly xn minus n will be cancel, and we have k into xn minus x0, and that is k into b minus a. So this is constant value. For any partition p we have the same value, and hence if we take the infimum of this upper sum, set of upper sum, we get the same value k into b minus a. K into b minus a, this is infimum, means this is upper integral of the function f into dx. Similarly, lower sum equal to small m1 into delta x1 plus small m2 into delta x2 plus small mn into delta xn. K into delta x1 plus k into delta x2 plus k into delta xn, and we arrive at the similar steps whose sum is nothing but k into b minus a, which is again constant for any partition. Therefore, supremum of this LP of constant value is again k into b minus a. Supremum means lower integral a into b, and which is k into b minus a. Here you can see that upper integral equal to lower integral and having the value k into b minus a, and as the upper integral equal to lower integral, the function is integrable, and hence integration of this function equal to k into b minus a. So this is the function, constant function, and we know that every constant function is integrable, and here we have proved that the function is integrable. We get upper integral equal to lower integral. Now let us check another function. Suppose my function is 1 for x is irrational, and it gives me 0 for x is a rational, and let us consider any interval a comma b. As usual, if we take partition p x0 x1 up to xn, then for any interval x0 to x1, here is x0, suppose here is x1, it contains the value of the function. There are infinite number of rational and irrational points. Hence at rational point we get 0 f of, suppose this is my number x dash, then, and if x dash is a rational number, then f of x dash equal to 0, we get 0. And if this number is x double dash, which is a irrational, x double dash is equal to, we get 1. So value of the function we have 0 and 1. If we have 0 and 1, then the infimum value is 0 and supremum value is 1. Therefore mi equal to 0 and capital Mi is equal to 1 in every delta xi. In every delta xi we have capital Mi equal to 1 and small mi equal to 0. So as upper sum is equal to capital M1 into delta x1 plus capital M2 into delta x2 plus capital Mn into delta xn. This gives me 1 into delta x1 plus 1 into delta x2 plus 1 into delta xn, which is nothing but b minus a, and which is again constant for any partition p. Therefore if we take the infimum of this upper sum, infimum of upper sum is nothing but an upper integral, and value of this upper integral is b minus a. Let us calculate the lower integral. M1 into delta x1 plus small m2 into delta x2 plus small mn into delta xn. What is the m1? M1 is 0. 0 into delta x1 plus 0 into delta x2 plus 0 into delta xn, and everything is 0. So value of this is 0 for any partition P, and supremum of this lower sum is equal to 0, which is nothing but lower integral. Hence you can see that value of upper integral is not equal to value of lower integral of the function. Therefore this function is not integrable. F of x is not integrable. So this is an example where the function is not integrable. Let us consider one more example so that your idea regarding this will be clear. F of x equal to x square, and the interval is 0 to k. We divide this interval into n equal parts: 0, 1k divided by n, 2k divided by n, up to nk divided by n. This is the n partition we have chosen. This is my P, where length of this interval delta x1 is equal to 1k divided by n is equal to k divided by n, delta x2 equal to 2k divided by n minus 1k divided by n equal to k divided by n, and in general length of each interval is k. Now f of 0 equal to 0 square is a 0, f of 1k divided by n is equal to 1 square k square divided by n square. F of 2k divided by n is equal to 2 square k square divided by n square. So these are the values. Now in the first interval you can see that this 0 is a small m1 and capital M1 is equal to 1 square k square divided by n square. In the second interval, this is M1, which is 1 square k square, M2 k square n square small m2, and capital M2 equal to 2 square k square divided by n square, right? So in the delta xi interval, small mi is equal to I minus 1 whole square k square divided by n square, and capital Mi equal to I square k square divided by n square. Now let us proceed for upper sum. Upper sum is capital M1 into delta x1 plus capital M2 into delta x2 plus capital Mn into delta xn equal to capital M1 1 square k square divided by n square, and delta x1 is k divided by n, plus capital M2 is 2 square k square divided by n square into k divided by n. K divided by n is a value of each subinterval. So here n square k square n square into k divided by n. Then you can see that we have k cube divided by n cube is a common, and 1 square plus 2 square plus n square. Now we have a standard formula for this n cube is n into n plus 1 into 2n plus 1 divided by 6. This n cube and this n, one n will get cancelled and we remain with n square. We write this n k cube divided by 6 into 1 plus 1 divided by n and 2 plus 1 divided by n. Okay, now we need to calculate the infimum. Therefore, infimum of upper sum will be get if limit n tends to infinity. If n tends to infinity, this becomes smaller and smaller value. So as n tends to infinity, k cube divided by 6 into 1 plus 1 divided by n into 2 plus 1 divided by n. This will be 0. This is 0 in the limiting case, and we have k cube divided by 6 into 1 into 2, and we have now k cube divided by 3. So the upper integral we obtained here is upper integral a to b f dx equal to k cube divided by 3. Then we find the lower integral. Similarly, the lower integral equal to, let us proceed to find the lower integral. What is lower integral? Lower integral definition, LPF equal to, LPF is nothing but small m1 into delta x1 plus small m2 into delta x2 plus small mn into delta xn. This is 0 k square divided by n square plus 1 square k square divided by n square into k by n. So we write directly take k by n as a common, and n square k square divided by n square, and each length is k divided by n. Okay, then k cube divided by n cube into 0 plus 1 square plus 2 square plus n square equal to k cube divided by n cube into k cube into n cube. This is n into n minus 1 into 2n minus 1. We have 2n minus 1 now. Then divided by 6. Okay. Again the similar process, k cube divided by 6 into 1 minus 1 by n into 2 minus 1 by n. Supremum will gives us when this value is 0, then we have maximum value 1, here we have maximum value 1. Therefore supremum of this LPF equal to limit n tends to infinity of k cube divided by 6 into 1 minus 1 by n into 2 minus 1 by n. K cube divided by 6 into 1 into 2, and this is nothing but k cube divided by 3. Here this is a lower integral. Then we have upper integral and lower integral have same value. Here upper integral of the function a to b equal to lower integral of the function, and hence the function is integrable. So the function f of x equal to x square over any over interval 0 to k is an integrable function.